All right, take a look at the sheet that you have. We've been reviewing how to find corresponding sides of similar shapes and corresponding angles. So let's start with the first one. You should have it in front of you, the little half sheet that I gave you. We're going to go over these quickly, and then we're going to talk about indirect measurement. So quadrilateral ABCD is similar to quadrilateral WXYZ. So we indicate corresponding angles with curved lines. So angle A corresponds with which angle? W, okay? So how you might know that, because it's kind of twisted, you see how the one shape on the right is flipped, is you can look at the order in which the name of the shape is given. So the angles should match up with the letters. So if A comes first in the first quadrilateral, W comes first in the second, those two match up, okay? So A goes with W, and then B over here is going to go with X. So B, you would have two curved lines, and X, you would have two curved lines. So when you're in doubt, if they give you the name of the shape with the letters, you can go by the letters to figure out which ones go together. So which angle goes with C? Yeah, C goes with Y. We can see from the picture, we can figure it out, and we can also see it from what's given for naming the quadrilaterals. So C goes with, there's no way that C goes with Y though. It doesn't. Okay, well according to this it does. Go ahead and just do it. According to what they've given you, it should work. And then Z would go with D. Z would go with D. So Z, 1, 2, 3, 4 would go with D. 1, 2, 3, 4. I recognize that it doesn't make sense with the shapes themselves because the angles look different, but we always are going to go by how our shapes are named, and if they're named that way, it should match up. Okay, so go by the name. There was a mistake in this picture. It should have been drawn differently, but you should go with how the letters are named. All right, let's look at the next one. This tells us that quadrilateral WXYZ is similar to L, M, and P. So we're labeling the measures. So if W, we know that W is going to go with L. So if W is 112, so is L, okay? Because we know that similar figures have congruent angles. You're writing this down on the paper that I gave you, the little half sheet. And then it says, okay, so if I know that X is 74, X goes with M. M is also 74 degrees. All right? If I know that Y, okay, I'm going to look over here. Y is 102. Y goes with N, so N is also 102 degrees. And then finally left with Z and P. They go together up here in the order. Z goes with P. So if Z is 72, so is P. Make sense? So what's true about similar figures is that their corresponding angles are always the same. They're always the same. And we could even look at that. If I were to trace this shape here, right, this one is similar. I should be able to take the shape itself and drag it. At least that angle there is working with me. You see how that angle matched up? Angle for N matched up with angle Y. So the angle itself, and I could go ahead and bring this. Maybe not. Maybe it's not going to cooperate with me. Maybe not. Yeah, let's not even try. Okay. So you guys get the idea that the angles of similar figures are always congruent. Let's take a look at the next one. All right, so now if you notice this time it's been turned. So this is telling us that ABCD is similar to WXYZ. So we're going to fill in the blank to figure out what WX goes with. So what I'm going to do here is I'm going to highlight or color in WX because I want to know what side length goes with WX. Now what I can do is I can look at the shape itself. I can see that it's turned, but to be sure I get this right one, I'm going to look at the letters. You see where WX is in the name of quadrilateral WXYZ? Okay, let's look at ABCD. So WX is placed where A and B are, so WX goes with AB. Because with a rectangle it would be hard to tell how it was flipped. So WX corresponds to AB. So when in doubt, look at how they're named to figure out the corresponding sides. All right. Next one. Now we're looking at angles. And again, we can look at the shape, and it's asking us to figure out which angle Y corresponds to. So for this one, what can I look at? The shape. If I look at the shape, it appears that it would go with C. But if you look at the way it's named, Y is actually going to correspond to angle what? B. Okay? It doesn't look like it, but we always go with how it's named, because the shapes are not always drawn correctly, but the way that they're named should be done correctly. So angle Y is actually going to correspond to angle B. Even though it looks different, even though B is obtuse and Y is acute, according to what is given, they're telling you those two are similar. Those are the ones that should be corresponding. Even though to our eyes it doesn't look that way. You're always going to go with similarity statements, and this is a similarity statement. If that similarity statement is true, then those two angles must correspond. All right. Number 5, quadrilateral ABCD is similar to WXYZ. Which proportion is true? Okay, so for this one, I would go ahead and color in my sides like we were doing before. Let's do that together. So AB goes with WX. AB goes with WX. Okay, do you see how I knew AB and WX go together? Because of the letters, right? AB has to go with WX. All right, so now let's take a look at AD. AD would go with what? WZ, good. WZ, because AB would be A and D go with W and Z, the first and last letters. Okay, and then my next one, DC. Okay, DC is right here, so that would be ZY. Good, ZY. Right there. And then, of course, our last two remaining shapes are going to be XY, right here, XY, and BC. That one actually makes sense, thank goodness. So now we can look at our choices. So this says AB is to WX as AD is to WZ, or AB is to WZ as AD is to WX. So which one do you guys think is correct? The first one or the second? The first one. Okay, let's check it. AB, so you've got your AB is to your AD. So AB, right here, and I'm just using my colors, is to AD. So let's see if they match up. As WX, which is green as well. Oh, excuse me, purple. WX, which is purple, is to WZ. You see how the colors match up with the corresponding sides? The colors are going to help you figure it out when you have sides, shapes that have many sides like this one. So we're going to say that this one is correct, that that proportion is correct. All right, a couple more. Okay, number 6, triangle ABC and triangle TUV are similar. Which proportion is a true statement for this situation? So what I want you guys to do is we're going to go ahead and figure that one out, and then we'll go over it. All right, so I've gone ahead and matched up my side lengths that are corresponding. And so based on this, I'm going to go through, and AB is right here. BC is here. So I'm putting color coding to check my work. And then TU is also green. TU is green. Oops, down here. And TV is actually red. So could the first one work? It doesn't match. You've got the red with the black and the red with the, the green with the black and the red with the green. So it's not that one. So it must be this one. But let's double check. AB is green. TU is green. BC is what color? Black. And UV is black. So those go together. Make sense? All right. We're going to go ahead and I'm going to leave those last two for us to start with tomorrow. And I want us to go ahead and start talking about indirect measurement, because I know one of the questions we might have is saying, well, who really cares about this? When would I ever have to use something like this in real life, or at least in math class? Like, what kind of problems would I have to do besides just matching up shapes? So one of the things that we can do using what we know about similar shapes is let's go ahead and look at this problem before we get into indirect measurement. Did you guys see one like this on your IXL? Okay, this one is a little more difficult. So I want you guys to copy this down at the bottom of your similar figures, more guided practice. At the bottom there, I want you to copy this diagram of these two triangles. It's actually one inside of another. I'll show you in a minute, okay? So I want you to copy it down as it is. And then I'm going to show you what I mean by two triangles. So basically, it's one triangle inside of the other. And I can tell you right now that they're similar. Okay, so these two triangles are similar. So I'm going to say that triangle JIF is similar to triangle JHG. They're similar triangles. One is inside the other. Can you visualize that, how they're inside one another? No? Okay, so let me show you. Let me show you how you can do this. So when you have a problem like this, and let's hope it'll let me do it. There's our one triangle. What you're going to want to do when you have something like this is to go ahead and draw them separately. So that's the smaller one, and then the larger one is here. So you've got two triangles. So this smaller one here is JIF, right? You see that? It's this one right here. It's what I took right here. And then the larger one is going to be JHG. So when you have problems like this that you're going to see on IXL, go ahead and use a piece of paper or dry erase board or something so that you can separate the two triangles out and then label their side lengths. So if I'm trying to find, well, I'm going to label what I know. I know that JI is 4, and I know that JH is how much? How much is JH? How much is JH? What's the value of JH? 8, right? And then I know that HG is 6, and what I'm trying to find out is P. So now what you're going to do is write a corresponding proportion. We have 2 minutes. You're early. So if you take a look, I can write a proportion with this. So over here, we're just going to quickly write a proportion. 4 over P. You see what I did? I took the 4 over P, is equal to 8 over 6. 8 over 6. Does that make sense? We've separated them out. We've put together our corresponding sides. I put this is to this. JI is to IF as JH is to HG. And now I'm simply going to solve for this. So 4 times 2. You could do cross products, but for this one, it's just easy to look at the relationship between 2 and 8. It's a times 4, or excuse me, a times 2. So then I have to figure out what number times 2 would give me 6. Yeah, so P is equal to 3. All right. Tomorrow we'll go ahead and fill out the second paper that I gave you, and we'll learn more about indirect measurements.